आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanta Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics, and its applications in various natural and social sciences. We welcome Dr. Amartya Dutta in this podcast, who is a professor at Indian Statistical Institute, Kolkata. Sir will be speaking on some aspects of ancient Indian mathematics.
I am Amartya Dutta, Indian Statistical Institute. I work in commutative algebra and affine algebraic geometry on one hand, and history of science, especially history of mathematics, especially mathematics of ancient India on the other. The Indian Mathematical Society had instituted award in history of mathematics, and I happened to be the first recipient of the award for an article on weighted arithmetic mean in India and Europe. There is a interesting background to it, that how I came to write on this topic. You know that Stephen Stigler is a big name in history of statistics and is a distinguished statistician. So he had given a talk in our institute, Indian Statistical Institute, on the first World Statistics Day. That was 2010. That is 20th October of 2010. That was the World Statistics Day, where he talked about the 5 great ideas in statistics which has shaped our way of thinking or completely changed our way of thinking. Later he expanded into 7 pillars of statistical wisdom. Now the first of these concepts, 5 or 7, is arithmetic mean, which I suppose everybody knows, that you have data, let us say heights of various people in a room, then what would be the representative height? So there are various measures of this central tendency, and the most common one is arithmetic mean, which is applied in all branches of science, including social science. So this he mentioned to be the first great idea. And he said that historians of statistics have done a lot of research and found that this idea emerged only in early 17th or late 16th century, and it is surprising that it doesn't occur earlier as a statistical concept. So I was surprised because in India, Brahmagupta in early 7th century, to be precise in 628 AD, has given the formula for weighted arithmetic mean. And in what context? So if you have a, let us say, irregular ditch or irregular pond where the depth varies at various places, then how do you represent the depth of the pond? So he breaks up the pond into various subdivisions where it is kind of, you can say, depth is nearly uniform, and then takes the depth of each part and then the weighted arithmetic mean of the depths of all these things. So this, the formula for weighted arithmetic mean comes out in Brahmagupta's work very naturally from a practical application. And this I had pointed out to Stigler. So when he later wrote the book, 7 Pillars of Statistical Wisdom, he did mention Brahmagupta and he had acknowledged me at the end. Now, this is something which I elaborated in an article in a mathematics magazine. It's an excellent mathematics magazine which has been started in 2017, from January 2017, named Bhavna. You know, when Manjul Bhargav got the Fields Medal in 2014, that was first great result that he had proved was on higher composition laws. That is how he shot into fame, and that he generalized results of Gauss, which nobody thought about that this could be generalized and simplified. He did it 200 years after Gauss. Now, the point is that the first person in history to talk about composition laws was Brahmagupta. Amazing what Manjul Bhargav described, that it just blows your mind. He did it in the 7th century. So when Manjul got the Fields Medal, then a few months after that, there was a History of Mathematics, International History of Mathematics conference in Pune, and I was requested to give a talk on the history of composition laws from Brahmagupta to Manjul Bhargav. And that composition law was called in India as Bhavna. So I gave the title Bhavna from Brahmagupta to Bhargav. So when the new mathematics magazine came, then the editor thought of the name Bhavna from there, because it is a tribute to Brahmagupta, allusion to Manjul Bhargav's getting this thing. So one high point of ancient Indian mathematics and one high point of mathematicians of Indian origin are doing currently. And it also has the nuance of reflection, contemplation, and it is very rich. The Sanskrit meaning is very rich. In the inaugural issue, I had written an article on this at the suggestion of Manjul Bhargav himself, where I gave the various meanings. But Bhavna in mathematics means the composition law. And incidentally, I have been writing a series of articles on mathematics in India from January 2022. It is still ongoing. And this gives a complete, I just take up a topic and give a complete picture around that. Weighted arithmetic mean was not part of the series because it was written much earlier in October 2017. So 2 articles. One is that the introductory article written at the suggestion of Manjul Bhargav was in January 2017. Weighted arithmetic mean, which you are referring to, was October 2017. But the series has started from January 2022. So when I'm given the details, it is not just what happened in India. I've also mentioned about what happened in Europe, the entire details, which are of course not the European things. The research had already been done and which I have kind of summarized. And in India, I have given the details which are scattered all over, but maybe not given in not given at one place. And those who have mentioned about this weighted arithmetic mean, they probably didn't realize the importance of highlighting it, and that's why it didn't get noticed earlier. And in this context, I've also explained that why it that Indians got this idea 1,000 years before Europe. The factors are the Indian strength in basic arithmetic, as well as in algebra. It is only, so Europe, you see that their research showed that it started appearing in Europe in 17th century. What is the significance of 17th century in Europe? That is the time the Indian decimal system had got introduced in Europe, and algebraization had also started. And as you know, the Indian decimal system is one of the pillars of the Renaissance, one of the factors which contributed to the economic, commercial, mathematical and scientific Renaissance in Europe, and therefore it is one of the pillars of modern civilization. And I'll tell you an interesting anecdote here. If you have watched this Amitabh Bachchan television show Kaun Banega Crorepati, in one of the shows, a mathematics teacher had argued that mathematics is not at all a difficult subject. He pointed out that while most students forget all other subjects taught in school, everyone remembers the fundamental arithmetic operations, addition, subtraction, multiplication, division, etc., that are taught at a primary stage in school throughout their life. But what was not mentioned in that program and not highlighted anywhere is that all these operations, they are of Indian origin. There is a slight modification because they were done in something like the slate chalk kind of medium, whereas now we write on pen and paper, ink and paper. That led to certain modifications, but the underlying principles are same. And so this basic arithmetic, and not just the fundamental operations like even square root is occurs in Aryabhata, for instance, square root, methods of taking square root and cube root. But entire arithmetic, let us say operations with fractions, the rules on ratio and proportion, like rule of three, which was called golden rule during the European Renaissance, the commercial arithmetic, income and expenditure, profit and loss, simple and compound interest, discount, partnership, computation of average impurity of gold, speeds and distance, mixture problems. All these things are of Indian origin, and surprisingly, it is not that well known in among not only children, but even among scholars. That is very unfortunate, because way back in 1814, Laplace had highlighted this. The great French mathematician Laplace had highlighted that it is India that gave us the ingenious method of expressing all numbers by means of 10 symbols, each symbol receiving a value of position as well as an absolute value. A profound and important idea which appears so simple to us now that we ignore its true merit. And we shall appreciate the grandeur of this achievement the more when we remember that it escaped the genius of Archimedes and Apollonius, two of the greatest men produced by antiquity. These are the words of Laplace, and there is no excuse for not knowing, because all the details have been documented in the great resource book History of Hindu Mathematics by Vibhutibhushan Dutta and Avadhesh Narayan Singh, written way back in the 1930s. And I've been, as I said, that I've been highlighting in my Bhavna article that how this arithmetic came about, how the algebraic thinking influenced the arithmetic, which I'm sure will benefit the thinking process of students, because students should learn mathematics, or for that matter anything, as a process of learning the art of discovery. And it is through history that the art of discovery can be promoted.
We feel enriched to listen to Professor Dutta in this episode as he shares his vast knowledge and experience.